Hi everyone. Today we're going to learn a new lesson. We're going to learn some new ways to find the area of triangles. We all know the formula for finding the area of a triangle as 1/2 the base times the height. But that only works when you know the height, which is always going to have to be perpendicular to the base. So sometimes it can be tricky figuring out what the height of the triangle will be. And we have some other formulas that we'll learn today that might help us so we don't have to find the height of the triangle. This other formula over here involves having a circle inscribed in the triangle. So this comes from your days back in ninth grade geometry, and you might remember the formula A equals R times S, where R, of course, would be the radius of the circle, but S is called the semi-perimeter of the triangle. So as far as semi-perimeter, if this was side A, this was side B, and this was side C, to find the perimeter, we know that we add up A plus B plus C. To turn this into the semi-perimeter, we would divide it by 2. So you would add up the three sides and divide by 2. And we're actually going to use the idea of a semi-perimeter in one of our formulas today. So this is how we can derive our first formula. And you can see here we have an oblique triangle. We have something that could be the base of a triangle, and the height of the triangle is given to us. But what if this height wasn't here? What if we didn't know this height? So we're going to derive another formula that we could use if we know other things about the triangle being an oblique triangle. So they're using the variable k right now to represent area. And they want to know what the area of the big triangle is. Well, using B being the base and H being the height, and they make a right angle with each other, so we can use that. We can just say the area is 1/2 the base times the height. So we're going to take this basic formula now and derive another formula that we're going to use today. Now they're asking us for the sine of angle A. Well, A is here, and you have to be working with a right triangle to use the sine. So I believe this little sliver here is a right triangle, and they want to know what would be the sine of A. Well, A would be the opposite over the hypotenuse, so H over C would be the sine of A. Now they want us to take that last equation and solve for H. So if we multiply C by both sides, we get C times the sine of A. And H was the thing that we might not have in our triangle. So now they want you to take that formula and plug it in here for H, and that's going to derive our brand new formula, which will be 1/2 the base times the height, which is now C times the sine of A. And these are now our new formulas that we can use for the area of an oblique triangle. You can see that there's 3 different versions of them. If you look at the variables for the sides, they do not match the letter of the angle. So if that's the case, like if this is angle or triangle ABC, and this is angle A, and this of course would be side B, and this would be side C, you have to know a side angle side situation to be able to do these formulas. So we have to know or be able to come up with side angle side. So for our first example, they switched up the letters for us. It doesn't really matter. This is triangle DEF. And they told us that small d, side D, is 13.9. Angle D we know, and I'm not going to write it in there just because it'll get too sloppy. And we also know angle E. Well, in order to do the area for this oblique triangle, we need to know a side angle side situation. Well, we can find sine angle side. The first thing we can do is we can find this angle F by subtracting those other 2 angles from 180. So we would take 34.4 and 14.8 and subtract that all from 180. And I already did this somewhere. That's 130.8 degrees. So now we know this is 130.8. Then by using our law of sines, we could set up a ratio or a proportion to find E. So E over the sine of E, which is 14.8 degrees, equals 13.9 over the sine of D, which is 34.4. And I already found E. Maybe I didn't find E. I found something different. Should have looked at my notes a little bit better. Okay, let's see. 13.9 times the sine of 14.8, and we're going to divide that by the sine of 34.4, and so E should equal 6.3. So now we have our side angle side. So now we're going to use our formula to find the area. So the area of this triangle is 1/2 6.3 13.9 times the sine of whatever F was, which was 130.8 degrees. And you can use any side angle side. You should always come up with the same area. And this turns out to be about 33.0, and this is area, so we should put some type of units like units squared there. Next, we have the area of a triangular parking lot. We probably should have started with an example like this one because they already gave us the figure, and you can see we already have side angle side. So this is pretty easy and straightforward for us. So we're just going to multiply 1/2 times 52 times 90 times the sine of 102, and you put that all into your calculator, and I got 2,288.9, and we're talking about meters squared. Next, we have a triangle to find the area of, and this time they gave us a side situation. So we know A, we know B, and we know C. So we have to find one of the angles. I'm just going to go with angle A. So we're going to find angle A because we have side using our law of cosines. So you got to go back to your law of cosines formula, which would be 5 squared equals 8 squared plus 9 squared minus 2 times 8 times 9 times the cosine of A. You're going to put in your calculator 5 squared minus 8 squared minus 9 squared. You're going to divide that by this product, and you're going to take the inverse cosine. And when I took the inverse cosine, I got 33.6 degrees for A. Now we have our side angle side situation, so we can find our area, which would be 1/2 times 8 times 9 times the sine of 33.6. We're using cosine here, but sine here. And when we put that all into the calculator, I got 19.9 square feet. So there is a formula that we can use if they give us side. So you wouldn't have to do the law of cosines to find a missing angle. Or you could always stick to that method. It's up to you. But this is just a new formula, and this is called Heron's formula. And Heron's formula, you can see, uses the lengths of all three sides. And here comes this variable S back in, and S means semi-perimeter. So first you got to find the semi-perimeter, which is adding up all three sides and dividing by 2. And then in the formula, you're going to multiply the semi-perimeter times the difference between each side, and then take the square root. So we're going to do this with the last example numbers and see if we get the exact same answer, 19.9 again. So first we have to find our semi-perimeter by adding up 5 plus 9 plus 8 and dividing that all by 2. And when you add that up, you get 22 over 2, which is 11. And then we're going to go and we're going to find the area. So we are going to take the square roots of 11 times 11 minus 5, which is 6, times 11 minus 9, which is 2, times 11 minus 8, which is 3. So you put that all into your calculator, and don't forget to take the square root, and you get 19.9 square feet. So we did get the exact same answer using our other formula too. All right, so now it's time for you to practice these formulas. You are going to have an assessment on today's lesson and the next lesson combined next week. And our next lesson is all to do with application in word problems. So in those word problems, you might be finding missing sides of the triangle, missing angles of a triangle. You might even be asked to find the area for some word problems. So we're going to combine this into one little quiz that you will have next week. So more about that later, but as for right now, just practice these formulas. And I'll see you in office hours.